Let's compare the number of circles in each box. If they are equal, write a number sentence. If they are not equal, write not equal. So the first set of boxes I see I have 3 plus 2 plus 1, and the second box I have 3 plus 3. If I were to count them individually, I have got 1, 2, 3, 4, 5, 6 in the first box. And on the second box, I have 1, 2, 3, 4, 5, 6. So I see that they are indeed equal to one another. The second set of boxes, I have 1, 2, 3, plus 2, plus 3, plus 3. These are in fact not equal, because on the left we've got 5 dots, and on the right I see I have 6. Which leads us into ways and strategies for counting. So I've got some counting techniques that are developed in kindergarten, and we're going to further develop these into first grade. So on the left, I've got counting all. This would be when we're using addition. So we would start with 1 and counting to find the total number of objects. So if I had 8 plus 4, we would start from 1, count up to 8. 1, 2, 3, 4, 5, 6, 7, 8, and count up 4 more, which typically is done with our fingers or using physical objects. So 9, 10, 11, 12. The counting on version, we count from the start number rather than starting at 1. So the same number combination, 8 plus 4, we would start at 8 and then count with our fingers 4 more, 9, 10, 11, 12. Or we could count all with subtraction. So we would remove the appropriate number of items. So we would have physical objects with us and count the remaining items starting with 1. So if I start with 12 counters, I need to remove 8 of them. So I would count out 8 to remove them. And I would see I had 1, 2, 3, 4 objects that are left. Or a little bit more sophisticated, we could count back. Start with the total and count back the number of being subtracted. So start with 8 and count back 8, one number at a time. And you could use your fingers to keep track of 8 spaces as you're going backwards. Count on with subtraction. Start with the change number and count on to reach the total. So start with 8 and count up to 12 by ones. And of course, when we get more sophisticated, larger numbers. So 8, 9, 10, 11, 12. I see that there were 4 spaces to get to 12. So some counting strategies that we learned in kindergarten, we are going to move them more sophisticated in the first grade. So if I looked at 5 plus 6, this could be considered as doubles plus 1. So we're decomposing the number 6 into 5 plus 1. So then 5 plus 5 we know is 10, plus 1 more is 11. Similarly, we could do doubles minus 1. So I could decompose 5 as 6 minus 1, knowing that the doubles, 6 plus 6 is 12, subtract 1. So more mental computation. I could make 10, decompose 4 into 3 plus 1, since I know that 7 plus 3 is 10, plus 1 more is 11. We could make 10, decompose 3. I need 2 more to get to 10, so 3 is 2 plus 1, which is 8 plus 2 plus 1. Count on 2 or make a 10. So I could decompose 2 into 1 plus 1 because I need 1 more to get to 10 with 9, or count on 9, 10, 11. And then here just count on 1, so 10, 11. Your homework, I want you to use pictures or diagrams and include word models to show the unknown in each of the following equations. This may be best using pencil or paper, or certainly use one of our online manipulatives. But use pictures or diagrams and include word models to show the unknown in each of the following equations, and then drop this in the counting strategies box. Okay, moving to number and operations in base 10. So now we're going to extend counting to 120, and we can pick up at any place in between to get to 120. Understand place value. So knowing that we can bundle 10 units into a group of 10. Use place value, understand properties of operations to add and subtract using 2-digit numbers. We can use number charts to develop all sorts of number senses. And even though the number chart I'm going to show you ends at 100, you could easily do these same items all the way up to 120. So let's go over them. The first one I'm going to show you is that all the numbers in each column have the same number in the ones place. So I've got this column here done, and I see that all the numbers have 2s in the ones place. So if I went to the next, all the ones 4s. Okay. Similarly, let's go on the rows. If I choose the row, all the tens digits in, well, to there I should say, all the tens digits are the same. You can also talk about reversed numbers. So if I had 17, the reverse number is 71, or 48 and 84, or 90 and 9, so that students understand that place is important, where it's located, 12 and 21. Also great to talk about numbers that come before or after. So if I slap 48, one more than 48 gives me 49. Or if we look at the number before the number that precedes 48, 47 is one less. We could further instigate that 10 more than 48 is 58, and 10 less than 48 is 38. So we can develop a number sense around an individual number based on the numbers that are around it. Count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. And students will begin to see that when they're counting, it creates a nice pattern in our hundreds chart, which you can extend to 150 as well. We can also count by 5s. 5, 10, 15, 20, 5, 30, 35, 40. And students will again are starting to see a pattern where these numbers fall. We can also count by 10s, 10, 20, 30. Again, finding a pattern of where these numbers fall with one another. So we learned in kindergarten that if we had a group of 10 ones, we could group them together and make one group of 10 and 0 ones. So I've got some base 10 pieces here. I've got 10 individual units on the left, and I'm going to group them into what we call a long or a group of 10 for now. We can extend this idea using the place value chart. So I've put my 10 ones into the ones column here. And I'm going to circle them because I have 10 of them and move that 10 into the tens column and create an individual long or group of 10. How could we represent 34 units using tens and ones? So imagine I have 34 units hanging around just randomly. I can start grouping them into groups of 10. So I would be able to create 3 groups of 10 with 4 units left over. We have 3 tens and 4 ones, which represents the number 34. When students get a feel for place value of tens and ones, they begin to naturally compare two numbers by looking at the number of tens and ones in each number. Beginning with concrete materials such as the place value chart or a number line, they'll be able to generalize that the number with the most tens is greater, and if they have the same amount of tens, the number with more ones is greater. So let's identify which is greater, 47 or 32. So I've got my place value chart. I'll have one chart for each item. I know that with 47, I'll have 4 tens and 7 ones, and 32 is 3 tens and 2 ones. 47 is more than 32 because 47 has 4 tens, which is more than 3 tens in 32. Which has fewer, 25 or 28? So we've got our place value chart, and I know that there are 2 tens in 25 and 5 ones in 25. I know that there are 2 tens in 28 and 8 ones. I know that 25 is less than 25 because they both have 2 tens, but 5 ones in 25 is less than 8 ones in 28. Using concrete models to develop and understand addition helps students generalize beyond basic facts and are able to progress to making generalizations and develop their own strategies. So let's show 23 plus 6 using base 10 pieces. So 23 is 2 tens and 3 ones, and 6 by itself is just 6 ones. I count that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 ones, so I do not have enough to regroup and make into tens. So 23 plus 6 is 29. I see that I don't have enough ones to regroup into a group of tens, so I still have 2 tens, and now I have 9 ones, so 29. You give this one a try. Show using base 10 pieces that 33 plus 50. Pause the video and only start it when you figured it out. So 33 is 3 tens and 3 ones, and 50 is 5 tens and 0 ones. I don't have enough ones to regroup, so I have 8 tens and 3 ones to make 83. Show using base 10 pieces 35 plus 7. 35 is 3 tens and 5 ones, and 7 is 7 ones by itself. Aha, I see that I have enough ones to make a 10. So I'm going to group together 10 ones to make a group of 10, which then leaves me with 4 tens and 2 ones. So I started with 3 tens in 12 units. I regrouped 10 units to make a 10, which gave me now 4 tens and 2 units, so 42. Homework. Use base 10 pieces to solve the problem and explain your thinking. So tell me in words what you did. 45 plus 36. Cinderella and Snow White each solved the problem using a different strategy. Take a look at each one of their strategies and then answer the questions A, B, C, and D. This may be easiest to use a manipulative. I've got base 10 pieces as a virtual manipulative, or feel free to do paper and pencil as well. Then upload to the appropriate location. I called it Cinderella and Snow White strategies into Moodle.